Signage and Wayfinding Design, a complete guide to creating environmental graphic design systems by Calori and David Vanden-Eynden. Chapter 2, The Design Process. Design is a creative problem-solving process. The design of signage and wayfinding programs is part of a broader design discipline that has come to be known as Environmental Graphic Design, or EGD. As defined in Chapter 1, EGD activity is concerned with the graphic communication of information in the built environment, which is just about anything built by human intent, be it a single building such as a hotel or stadium, an assemblage of buildings such as a city or campus, a planned open space such as a park or historical site, or a transportation network such as a subway or rail system. While the primary communication goal of signage and wayfinding design is to help people navigate the built environment, EGD encompasses two other important communication functions: placemaking and interpretation, and signage design often intersects with these other EGD activities, as discussed and illustrated in Chapter 1, What is Environmental Graphic Design? Though this book focuses on the signage aspect of EGD, the terms signage design and EGD are used interchangeably. EGD exists in a broader design universe and is, in fact, the ultimate hybrid, or, if you're less charitable, mongrel of design. EGD is the ultimate multidisciplinary design discipline, where graphic design, architecture, industrial design, interior design, landscape architecture, city planning, and urban design all converge, and common to all of these design disciplines, including EGD, is the design process, also known as design thinking. Design thinking has been adopted by various non-design organizations as a novel problem-solving approach in their arsenal of management techniques. While the name is different and the approach may involve fewer, differently named steps, the process is essentially the same. If considering this chapter to be about design thinking helps you better understand the design process, that's fine by us. All design activity is a problem-solving process. All design activity is also creative, but unlike fine art, it takes place under real-world constraints. Designers focus their creative talents on solving problems for their clients, not on self-expression. We, as designers, have a unique gift to give: life to our clients' ideas, which we make tangible and real. It's a heady responsibility, one we must undertake with diligence and good stewardship. We must consider all things possible to the extent possible. Moreover, we must extend our best effort to employ our creative talents, skills, and knowledge in making the world a better place. Designers, including EG designers, typically do not directly produce the objects of their design/creative activity. Unlike painters who put their creative compositions on canvas with their own hands, designers rely on other parties to produce the objects they design. There's the architect, who designs a building but relies on a contractor to build it. The industrial designer, who designs a consumer product but relies on a manufacturing facility to produce it. Or the traditional graphic designer, who designs a book but relies on a printing facility to print and bind it. The EG designer relies on a sign fabricator to build and install a signage program. A key role of the designer emerges in the preceding examples, that of an intermediary between the client and the producer, and between the design problem and the embodiment or realization of the design solution. See Figure 2.1. In this rule, the basic process any design professional uses becomes evident. It is to: number 1, assess the client's problem. Number 2, apply creative skills. Number 3, synthesize a solution. Number 4, communicate the solution to the producer. Number 5, oversee production of the solution. And number 6, evaluate effectiveness of the finished product. The universal design process is evolutionary. with the design solution unfolding in a series of steps from general to more specific. And while the steps or phases of the design process typically progress from one to the next in a somewhat systematic, linear order, they may at times overlap, repeat, or feed back into each other. Ultimately, however, the end goal is to progress from the first phase to the last, and every effective designer on the planet employs essentially this type of systematic process to arrive at design solutions, whether he or she is consciously aware of it or not. The client is part of the process. When a client engages any designer, including EG designers, a partnership is formed. With both clients and designers performing various roles, the designer's role is to make a diligent, earnest effort to solve the client's problem. The client's role is to provide adequate information, feedback, and guidance in a timely manner, and to pay the designer's invoices on time. Most successful projects are the result of an active working relationship grounded in mutual trust between client and designer. Message to designers: the client is part of the process, so don't ignore the client's needs and constraints. Message to clients: you are part of the process, so don't think the designer can magically solve the problem without your active involvement. Effective design solutions require client input and engagement. Passivity on the client's part doesn't work. If both clients and designers remember that they have a partnership and all that this relationship entails, a successful outcome is likely to result. The design process applied to EGD. The basic design process can be effectively tailored to EGD scenarios, maximizing the efficiency of EGD activity. Because so many EGD projects are coupled with architectural design projects, the design phases of the EGD process model outlined in this chapter are analogous to those used in the architectural profession. This process model is also a useful framework for outlining design services to be performed on a project in fee proposals to prospective clients. Additionally, it's useful for educating clients about the evolutionary process from which design solutions emerge and become implanted. The design process model, which includes a pre-design, design, and post-design phases, is shown in Figure 2.2. Each EGD phase, described in sequence in this chapter, has several tasks associated with it. Keep in mind that though these phases are presented as distinct and in linear order, they often overlap and feed back into each other, as noted previously. Also, be aware that while the client's involvement is mentioned primarily at project milestones, the designer typically maintains ongoing contact with the client throughout all the phases. Coordinating timing of the EGD process. If a signage project is independent of any larger design and construction project, the design process timetable can be set fairly easily. If, however, a signage project is part of a new construction project, timing of the EGD process with that of the overall project becomes critical. Often, EG designers are brought into a project too late, but they can also be brought in too early, such as before floor plans are frozen or locked. That is, while the plans are still in a state of flux and sign locations cannot be pinned down. Ideally, the signage design process should lag behind the architectural design process by 1 or 2 phases. While on the subject of time, note that signage projects are usually of much longer duration than typical graphic design projects for print or electronic media. It is not uncommon for a signage project to take months or years to complete. Although the EG designer may not be working continuously on the project during that time frame, So, EGD is definitely not for those who seek instant gratification in their work. Throughout this chapter, the design process is illustrated with photos that trace the development of the One Raffles Quay ORQ signage program at our office. From the data collection and analysis phase through to the fabrication/installation observation phase. The end product of the design process for the ORQ project, the Built Signage Program, is depicted in the gallery section at the end of this book, as are sign programs, which are the built products of the design process for our office and many other EGD consulting firms. Our office designed the ORQ signage program for a very large, approximately 2 million square foot office complex in Singapore, which has several mixed-use components, including below-grade connections to the metro rail system, above-grade parking facilities and pedestrian bridge network, and retail shops on the lower level. We designed the ORQ's sign program with a harmony strategy, as described in Chapter 1, to create a strong, unique brand image inspired by the lantern-like forms and transparency of ORQ's two office towers. The ORQ signage program has been internationally recognized for design excellence in many awards programs and publications. Phase 1. Data collection and analysis. Pre-design. Also known by terms such as pre-schematic, research, discovery, and others, this is a very important pre-design planning phase that often neglected by the designer's eagerness to get the creative juices going. But remember that design doesn't happen in a vacuum. You have a client who has engaged your services to solve a signage problem, and that client and that problem come into a whole range of parameters and constraints that you need to know about before you put pencil to paper or mouse to mouse pad and begin to synthesize an effective design solution. Put simply, phase 1 is the information gathering and analysis phase, the discovery or learning phase. During this period, EG designers collect as much information as they can on the fledgling project and then make sense of it. Examples of types of information studied and analyzed during this phase are shown in figures 2.3 through 2.5. An appropriate description of the designer's role in phase 1 is that of a sponge, absorbing and assimilating as much about the project as possible, then filtering that information into a plan of action. At first, phase 1 is focused on divergence, when the designer reaches out and plucks as much information about the project as possible with little regard to its ultimate usefulness. At this stage, it's important to be open-minded and non-judgmental about the data being gathered. As more is learned about the project, phase 1 activity becomes more convergent. Now the designer analyzes and distills the information to draw a conclusion and sets goals for the subsequent design-oriented phases. Subjects for upfront research can vary widely from project to project, but some basics for signage programs include, in no particular order, time and budget constraints, image and branding goals, formal and thematic contexts of the sites, user profiles, physical characteristics of the site itself, circulation pathways and decision points, applicable codes affecting signage, decision-making and client contact protocols, whether the client hates the color blue. No doubt, both you and your client will be impatient to get to the really fun, pretty picture phases of design, but it's important to keep in mind that the careful planning of phase 1 sets the stage for more focused, viable solutions in subsequent design phases. Remember to find out what you're jumping into before you jump in. Remember, too, that while the big research push occurs at the beginning of a project, Data collection and analysis often continues throughout the project. Phase 1 Goals and Results. The primary goal of the data collection and analysis phase is to gain a comprehensive understanding of the project at hand and to verify that your understanding meshes with that of the client. Phase 1 results in conclusions drawn from the data collection and analysis activity, as well as a plan for moving the project forward. Various diagrams and lists may be generated, as well as sketches, photo/video surveys, and other records. These may be informal working tools just for the design team's use, or they may be formalized for presentation to the client in a written report or visual presentation. In either case, the Phase 1 results should be reviewed and discussed with the client. Phase 2, Schematic Design. Once the pre-design project research and planning phase is completed, the EG designer should have a good grasp of what the project entails, and a focused design effort can begin. The schematic design phase is the initial design phase and is undoubtedly the most creative, exciting phase, for it's when the informational and visual foundations of the signage program are laid. Initially, schematic design activity is divergent and exploratory, with the goal of generating as many ideas, concepts, and approaches to the design problem as possible, and then becomes convergent as these various schemes are evaluated and selected. Overall, subsequent project phases continue to be convergent as the selected design solution is refined and finalized. This divergent-convergent aspect of the design process is illustrated in Figure 2.6. The visual aspects of a sign program are deeply influenced by its informational aspects, so it's important to start Phase 2 with exploration of the program's information and content system. Briefly, this includes determining the locations and communication functions of key signs in the program, as well as generating approaches to sign message, nomenclature, and hierarchy. In this process, the designer begins to formulate the building blocks such as communication functions, message vocabularies, mounting conditions, and viewing distances that are expressed in the visual aspects of the sign program. This activity will provide the designer with an inventory of key signs that represent the range of signs the program will encompass. This key sign inventory then becomes the focus of the visual concepts generated in schematic design. Chapter 4, the Information Content System, has a more detailed discussion on developing the sign information content system, an activity that's often referred to as programming. While it's essential to address the signs program's informational aspect early on in the schematic design phase, most designers focus their creative energies during this phase on the sign program's visual aspects, the graphics and hardware. See Figures 2.7 through 2.10. The creative juices and wild concepts should flow freely during the early stages of this phase. No holds barred. This is divergent ideation portion of Phase 2, where the goal is to generate as many rough visual concepts as possible, where every little inkling of an idea is explored and no idea is negated/judged until later. The key word here is rough. Schematic design should not delve too deeply into detail. A tip for improving concept generation at the beginning of Phase 2 is to never fall in love with your first, or any, idea. If you do, you run the risk of investing too much time of your time, effort, and ego into a so-so concept, when other absolutely brilliant ones could be out there just waiting for your discovery. And when you invest too much of yourself into one concept and detail it to death too early, you become reluctant to give it up, thereby blinding yourself to potentially exceptional concepts. Another tip, it may take a while for ideas to emerge. The creative mind often needs what is sometimes referred to as an incubation period to formulate concepts and ideas subconsciously. When this is enabled, often a great idea will just pop out, sometimes at seemingly odd moments, such as in the shower or at the grocery store, in what's known as the eureka or aha phenomenon. So be aware that creative ideas can take some time to emerge, although a deadline has a wonderful way of focusing the mind. More brains generate more ideas, so it's often productive to gather as many designers as possible within the EGD firm to participate in the ideation stages of Phase 2. Even if some of those designers may not be assigned for the duration of the project, collaborative brainstorming and word association techniques can stimulate the flow of design concepts, as can pencil and paper sketching versus computer rendering, as the computer interface is not as simple and direct as hand sketching. Some EGD offices, in fact, don't permit computer use in ideation, in part because computer use tends to foster endlessly minutely detailed variations on a possibly mundane idea rather than exploration of many truly novel ideas. Pinup sessions, too, are very useful for comparing and cross-fertilizing ideas and concepts. The concept sketches generated by the EGD team are pinned up on the wall and discussed among the team, with each designer articulating and thinking beyond his or her various ideas. These pinup sessions can be both convergent and divergent. Some concepts will be rejected, but even rejected concepts can stimulate entirely new directions. So plan on at least 2 pinup sessions to get out the ideas and check your ego at the door. As Phase 2 progresses, it becomes convergent as concepts for the design program's visual aspects are weighed and selected to form clear design directions to finesse for presentation to the client. As with ideation, concept selection should be a team effort, with each concept thoroughly debated, defended, and discussed in relation to how well it points to a solution to the client's problem. The key phrase here is pointing to a solution. Remember that the design process is evolutionary, that schematic design is an early phase of that process, and that the various problems and subproblems of the design program will be solved as the process unfolds in subsequent design phases. See figures 2.11 and 2.12. Think of Phase 2 as skimming the surface of the solution, and you won't run the risk of becoming too invested too early in what might be a wrong solution. This is not the phase for working out the details. The culmination of Phase 2 is a presentation to the client of the EG designer's schematic design activity. See figures 2.13 through 2.15. This is typically the first time the client is presented with the visual fruits of the designer's creative labors, so it's a major project milestone that either sets the tone for the rest of the project or sends the designers back to the drawing board to seek other design directions. If the designer has conducted thorough research, however, the need for visiting other design solutions is minimized. Another strategy is to fly some preliminary concepts by the client on an informal basis to test the waters, to gain input that you're on the right track before investing in an elaborate schematic design presentation. Many EG designers present up to 3 schematic design directions, explain the merits of each, and then gently guide the client towards the selection of one concept. Some designers present just one design concept and advocate forcefully for its adoption, which minimizes the risk of the client creating a camel, that is, an awkward combination of 2 fundamentally different concepts. The drawbacks to the single idea approach are that the client may 1. Reject the concept outright, and or 2. feel that the designer is being too dictatorial by not presenting enough options. Indeed, the designer should have discovered in phase 1 whether the client wants multiple options. The key to presentation of multiple concepts, however, is to not overwhelm the client with too many options, or with any option that the designer doesn't believe to be viable. In other words, don't show the client a direction you don't believe in, because that may very well be the concept the client selects, and you'll be doomed to struggling with it for the duration of the project. Phase 2 Goals and Results. The primary goal of the schematic design phase is to generate and present informational approaches and visual concepts for client review, selection, and approval in order to proceed to subsequent design phases. Another goal is to obtain client input and feedback that may affect the basic informational or design directions of the sign program. Phase 2 results in presentation materials that convey the schematic design concepts and approaches to the client. Depending upon the size and nature of the project and client, these presentation materials typically consist of an AV presentation in the form of a PDF or PowerPoint/Keynote file, which may be supplemented by material boards, study models, or other visuals such as animated fly-throughs. The client may also wish to have a printed booklet or an electronic file of the AV presentation. A basic content checklist for the Phase 2 presentation includes the items listed below. Of course, the EG designer can supplement or omit these basic content items as appropriate to a given project. Overview of the project. Context, including surveys of existing conditions if available. Key sign locations in plain view. Approaches to sign message, nomenclature, and hierarchy. Evocative or metaphorical references, typically images. Typeface and symbol options. Material and color palette options. Basic elevations of key signs, including scale references such as people, cars, and trees, and so on. Perspective montages of signs in their environmental context, using renderings or photos of the actual site as underlying images. Animated fly-throughs of key sign location areas to illuminate the signs within space/time sequence. Basic study models of sign forms and shapes. Persuasion is certainly part of the design process, as is the ability to articulate and present your concepts effectively, sometimes in formalized situations and before large audiences. Whatever the context, successful presentations are visually compelling and verbally engaging, and clearly speak to the client's design problem. In an ideal world, the schematic design presentation is a huge success and the client makes an immediate or at least prompt decision to select and approve one of the presented directions. So on to the next design phase, but not until you have clear client input and approval to proceed, especially because some clients take more time than others to reach decisions. And keep in mind that occasionally the designer must point to the project time schedule and gently prod the client to make a decision. Phase 3, Design Development. Approval has now been granted to proceed further onto the design process, and design development, DD, phase begins, whereas the initial stages of schematic design, SD, are divergent, seeking many ideas. DD continues the convergence of the later SD stages to focus more deeply on the selected schematic design direction. Phase 2 just skims the surface of the design solution. It is during DD that the solution is fleshed out, filled in, modified, and refined. See figures 2.16 and 2.17. The methods for documenting and tracking various project elements are also solidified in Phase 3. As in Phase 2, it is important to tackle the sign information content system in the early stages of design development. During Phase 3, a complete inventory of all the signs in the program must be developed, meaning that each and every sign must be located, messaged, typed, and assigned a unique identifying/tracking code. This sign inventory process is essential because the EG designer cannot meaningfully proceed with the design of the visual aspects of the program until all the particulars of its parts are known. In other words, the designer must know the physical conditions, such as width or height constraints, as well as the specific message content of each sign before it can be designed. Human factors, such as viewing angle and distance, as well as code-mandated factors, such as typographic sizes, also affect how each sign is designed, as described in more detail in chapters 4, 5, and 6. Comprehensive sign programs are composed of hundreds, even thousands of sign units, so it's inefficient from both design and manufacturing standpoints to design each and every one of them individually. Therefore, after sign locations and messages are established for the information content system, the designer can begin to look for commonalities among the various signs to group them into standardized sign types. The objective of sign typing is to reduce and simplify the sign program into the fewest number of groups that share common features standardized for each type, while still fulfilling the communication function of the sign program. In a simple example of sign typing, assume the EEG designer has located and messaged ceiling-hung, freestanding, and wall-mounted plaques within the project environment, and that they all have message content of varying length and importance. The first obvious common characteristic by which certain signs can be grouped together is mounting method. For example, sign type A is a ceiling-hung sign. Sign type B is a freestanding sign, and so on. Then, when message length and importance is considered, sign types can be further differentiated. For example, sign type A1 is a large ceiling-hung sign to hold message content of the largest quantity or highest importance. Sign type A2 is a small ceiling-hung sign to hold message content of lesser quantity or importance. Many other factors can also affect the development of sign types, such as low ceiling clearances requiring the use of a smaller ceiling-hung sign type at certain locations, or narrow corridors that limit a sign type's width. Figure 2.18 shows a list of sign types and quantities for the ORQ project. When signs are typed accordingly, the designer gains efficiency and visual unity by designing the sign type, which can cover a large quantity of sign messages and units rather than designing each individual sign as a unique, standalone object. And sign typing improves resource conservation and manufacturing effectiveness because, for example, several units of the same size and shape can be cut, formed, and assembled more efficiently than if the same quantity of units were all of different sizes and shapes. If you think of sign typing as designing for limited mass production, the usefulness of typing becomes clear. And from a design point of view, visual order is enhanced with fewer sizes, proportion, and shapes of signs in the project environment. The best way to track and manage sign types is by keeping a list that defines the characteristics and size of each type. Pinning down size types is, however, a balancing act, as sign types typically evolve and mutate as the DD phase progresses. For example, the need for new sign types may emerge. Some sign types may be deleted. Two sign types may merge into one, or the definition of a sign type might change. Methods for designing sign types vary, but the two basic approaches are to type signs by physical characteristics. such as size, shape, material, mounting method, graphic application technique, and so on. Communication function, such as whether the sign communicates identification, direction, or another kind of information, as described in more detail in Chapter 4, the Information Content System. At C&VE, Calori and Vanden-Eynden, we prefer to type signs by physical characteristics, as they most directly translate into drawings, schedules, and bid forms. Our thinking behind this is the primary fabrication cost factor of a sign is its physical characteristics, not the kind of information it displays. For example, a 12-inch square wall-mounted aluminum plaque with two-color silk-screened graphic costs the same to fabricate and install regardless of whether it displays identification or directional information. And a 12-inch square wall-mounted bronze plaque with two-color silk-screen graphics costs more to fabricate than the aluminum plaque with all the same characteristics. In this example, the material aluminum versus bronze is the distinguishing factor between these two signs, so we define them as different sign types. Other EGD practitioners type by communication function rather than physical characteristics, and sometimes signs are typed using a combination of physical characteristics and communication function. There is no hard and fast rule for sign typing, but as recommended by EGD pioneers John Follis and Dave Hammer in their seminal book Architectural Signing and Graphics, Whitney Library of Design, 1979, all signs in a given sign type should have the same size, shape, and method of attachment to the building. We agree with this recommendation. Regardless of the sign typing technique you choose, each sign type is assigned a code, typically alphanumeric or a combination of the two. This code is a shorthand way to refer to everything that comprises a given sign type. For example, the aforementioned sign type A is a code that succinctly refers to a large exterior, internally illuminated, ground-mounted pylon. As such, the sign type code is an essential element of the sign message schedule, which is used to track and inventory each and every sign in a program. During Phase 2, key signs may be numbered, but it is during Phase 3 that the sign numbering system for tracking all the signs in overall project is typically established, as that's when all the signs in a program need to be located on plans and entered into a messaging schedule. The sign numbering systems, sometimes called the location numbering systems, identifies and distinguishes each sign unit on the location plans and the message schedule. The sign numbering system is itself a coding system that conveys distinguishing information about each sign unit. To effectively track all the signs in a program, each sign should be assigned a unique sign location number, meaning it's not duplicated somewhere in the program. Other information about the sign unit, such as its sign type, which floor the sign is on, or whether it's an interior or exterior sign, can also be coded into its sign number. There are several approaches to sign numbering, some of which can be quite complex. A numbering system that's suitable for one project may not be for another, so it's wise to weigh various sign numbering approaches carefully before putting a given system to use. Because it's tedious and time-consuming to completely revamp the sign numbering system, once sign numbers have been entered on location plans and the message schedule. See figures 2.19 and 2.20. The sign location plans indicate on plan drawings each sign in a program, along with its identifying sign or location number. This sign number is entered into the sign message schedule, which contains all the essential information about each sign unit, such as its sign type, if it's not a component of the sign number, message, including arrows and symbols, plan drawing number, construction drawing reference, if applicable, mounting drawing reference if applicable, graphic layout reference if applicable. Most message schedules also contain a remarks column for tracking such items as changes, additions, deletions, signs for which client inputs is required, and so on. Message schedules are formatted as tables, typically on letter-size landscape, horizontal pages. EGD practitioners can use a range of applications to generate message schedules, from word processing applications for relatively simple small sign programs to spreadsheet and database applications, which provide more powerful, sophisticated tools for data entry, sorting, searching, and editing functions. All of these functions are definitely required during the development of a message schedule for large, complex signage programs, and in such cases, a database application is the most powerful tool. A word about computer platforms. Most EG design offices operate on the Macintosh platform, while most clients, including architects, are on the PC platform. This situation creates some file exchange issues, particularly with message schedule files, the EG designer's drawing files, and architectural CAD files. In the case of message schedules created in a database, most clients don't have database programs in their desktop applications, but they do typically have spreadsheet and Acrobat Reader applications. Therefore, the database message schedule may need to be exported to either spreadsheet or PDF format, which is easily accomplished. A spreadsheet format allows the client to edit the message schedule if that's desirable. PDFs should be considered uneditable unless the client has the full Adobe Acrobat Pro application. Regarding the exchange and display of other kinds of files developed by the designer or the client for a project, the PDF format facilitates this process, particularly for the EG designer's Adobe Illustrator AI drawings and the client's architectural CAD files. And yet, another word about computer technology and cross-platform matters. In lieu of CAD, more architectural offices are using Building Information Management, BIM, programs to accomplish their work. It's not the purpose of this book to explain PC-based BIM and how EGD may or may not relate to it. Suffice to say, the EGD offices are devising their own ways of adapting to the cross-platform issues and opportunities BIM provides. Sign location plans are prepared by placing a marker indicating each sign's location, along with its identifying number, on base plan drawings of the project. Most clients possess or can provide architectural plan drawing files, so the designer should always request those files, typically as PDFs, for use as the sign location base plans rather than going through the time-consuming effort of creating them anew. The sign locations and numbers need to be clearly visible on the sign location plans, but this is easier said than done because plan drawings are typically cluttered with written information such as notes, dimensions, symbols, etc., which is necessary for construction of the project, but tends to obscure sign locations. Nevertheless, there are several ways to increase the prominence of sign locations and numbers. Always request clean base plans with the written information removed if possible. While this is a relatively easy process if the architectural drawings were created in CAD, some clients may not want to take the time. If the plans are from a pre-CAD era, just be happy that the drawings exist at all, and take them however you can get them, making sure to check that they reflect the currently configured plan. Whether the plans are clean or not, they should be grayed back so that they're still readily visible but faded into the background relative to the sign locations and numbers, which are not grayed back. Enclose the sign numbers in a distinctive shape that stands out visually. from the plan background and any architectural symbols or shapes on it. Another consideration is color coding on final plan drawings. While many organizations are reducing their resilience on paper prints, and while full color printing has become relatively widespread and affordable, some parties that use the signage drawings may still be using paper prints reproduced in black and white. The techniques outlined here don't rely on color to distinguish sign locations and numbers, and therefore result in drawings that are readable when reproduced in either black and white or color. When it comes to size, because plans are typically generated at small scales, the sign locations often need to be indicated at a scale larger than that of the base plan in order to be visibly prominent. This alarms some clients, however, because they think that there's too many signs or that the signs are going to be really large or that they're too close together, so some explanation of the scale discrepancy may be necessary. There are projects where indicating the signs in scale on the plan is useful and necessary. In some cases, the base plans must be of adequate scale so the signs can be accurately indicated and seen in the same scale, which may result in several plan sheets with match lines for a given area. Another advanced caveat: the sign locations and numbers can crowd each other on some plans, so give some thought to arranging them in an orderly fashion. Another recommendation is to pull out the sign numbers beyond the plan footprint to help keep the plan itself uncluttered and readable, but this, too, requires careful arrangement. As the information content system is developed and tracked in the DD phase, the design of the visual elements, the sign graphics, and hardware also progresses, as shown in figures 2.21 through 2.25. During DD and the EG designer begins to address the details of the graphic systems and the hardware system. To solve the subproblems that lie in those details, the EG designer can use scale and full-size models and mock-ups, drawings, including 3D computer renders, and even design prototypes to study and refine those all-important details that contribute so much to the quality of the final sign objects. As the famed modernist architect Mies van der Rohe said, "God is in the details." Phase 3: Goals and Results. The primary goal of the design development phase is to solidify and refine the conceptual direction selected at the end of Phase 2, and to obtain client input and approval before proceeding into final documentation of the signage project. Phase 3 results in several items that convey the evolution of the informational and visual aspects of the design concept to the client. At this very least, these items include sign location plans in progress, message schedule in progress, drawings showing development of sign graphics, drawings showing development of sign hardware. Other items that may or may not be reviewed with the client include study and/or presentation models, 3D computer renderings, full-size mock-ups. Depending upon the project's requirements, the EG designer might make a formal presentation during or at the end of Phase 3, or may just submit a progress set of the location plans, message schedule, and design drawings for the client's review. In either case, client input on the development of the sign program's details is essential through the DD phase, and the EG designer should seek the client's review and approval of the sign program's development before proceeding into the documentation phase. Phase 4: Documentation. The documentation phase, which is the final design-centered phase of the design process, begins upon the client's approval of the work accomplished in Phase 3. Phase 4 continues the convergent activity of Phase 3, honing in on detailed solutions and refinements to the subproblems of the sign program. The goal of the documentation phase is to convey the design intent of the sign program to sign fabricators for pricing and production. In other words, the EG designer works out all the details and ties up all the loose ends of the sign program's design before it gets priced and built. The documents that work together to convey this design intent include sign location plans, message schedule, design drawings for the sign graphics and hardware, specifications. Note that work on most of these documents was started in the design development (DD) phase, and that the documentation phase is aimed at filling in and finalizing the information contained in these documents to provide fabricators with a complete picture of the sign program's design. See Figure 2.26. Before the documentation phase begins, the EG designer and client should agree on the format for the signage design documents. If that discussion has not already taken place, this includes the final sheet size of all documents in the package, whether the signage package is a standalone or part of the document package for an overall construction project, which often happens when signage is part of new construction. It also includes the title block, whether the EGD firms own or that of another party, such as the project architect. Title blocks appear on all drawings and contain general project and specific drawing information, such as drawing number, drawing title, date, scale, and so on. Remember, if the project is overseas, paper sizes and proportions are different from those in the United States. As in Phase 2 and 3, and it's important to focus on the sign program's information content system in the early stages of the documentation phase. It's time to nail down every last sign location and message because, inevitably, a few will still be left open from the DD phase. Only when the sign locations and messages are finalized can the details of the sign graphics and hardware be finalized. As resolution of these visual aspects of the program is contingent on the quality, kind, and viewing conditions of the information displayed on the signs. Finalizing sign types. The documentation phase is also when sign types are finalized to address the few that may have still been in a state of flux during Phase 3. Keep in mind that, at the very least, the sign type is keyed into the message schedule and is perhaps part of the sign number keyed on both the message schedule and the location plans. In either case, sign type revisions are tedious because they must be tracked and updated in the schedule and perhaps the plans as well. That said, if sign typing was carefully considered during Phase 3, the need to revise sign types during Phase 4 should be minimal. But there's always the possibility that the definition of a given sign type needs to be changed, or that a type needs to be added or deleted for the final project documents. The sign message schedule is the master inventory list for the entire program, which is why it is updated and finalized during Phase 4 with all changes, additions, and deletions to sign messages and sign type/numbers. Sign or location number and perhaps type changes must also be updated on the final sign location plans. Additionally, drawing reference numbers are entered into the message schedule as final drawings are generated for the sign graphics and hardware. This work is very tedious because each sign needs to have its own unique number, and that number needs to be the same on both the sign location plans and the message schedule. The reason each sign needs its own number is because, with the exception of some repeating messages, like women's restroom wall plaques, each sign has its own location-specific message, such as a room number plaque. Directional sign messages are even more location-specific, since destinations change along circulation paths. Thus, sign program message schedules are more complex than architectural door schedules because most signs in a program communicate a unique location-specific message. Software developers have, at various times, grappled with easing and automating this aspect of signage documentation, and some EG designers are successfully using such applications for this task. Just as the message schedule and location plans document the sign program's information content, the design drawings document the visual aspects of the sign program, often called working drawings or design intent drawings. These drawings convey the details intrinsic to the design of the sign graphics and hardware. Deciding on level of detail in drawings. The eternal question on design drawings is how much detail needs to be conveyed in order to obtain clear apples-to-apples pricing from fabricators. Thus, this is where the distinction between design intent and working drawings comes into play. It's generally understood among EGD practitioners that design intent drawings contain just the amount of detail that's required to convey the intent or outward appearance of the sign program's design. In contrast, working drawings contain a higher level of detail, typically regarding how the signs could be built. It's important to note that most EGD practitioners are typically trained in graphic design. Since they don't have training in engineering or architecture, they are not qualified nor licensed to perform either of these services. Signs, particularly those that are large, electrified, or similarly complex, and their connections to adjacent surfaces, need to be engineered. This is typically the responsibility of the sign fabricator, but some clients want signs to be engineered as part of the design documentation. In these cases, the EGD firm will need to engage the services of a licensed professional engineer. Along the continuum of design intent to working drawing details, it's impossible to degree the appropriate amount of detail for any given project, design firm, client, or perhaps most importantly, budget. Accordingly, this section focused on the core or essential information that needs to be conveyed in the drawing for a sign program. See Figure 2.27. As noted earlier about sign location plans, the design drawings shouldn't necessarily be prepared assuming they'll be reproduced in full color. In other words, it's wise not to rely on the use of color to communicate important information. For example, if a sign background color is blue, it should be noted as such in writing on the drawing. If this is not so noted and the drawing is reproduced in black and white, there is no way to know that the sign background is blue. These annotations, which indicate colors, materials, finishes, and so on, are referred to as callouts. Dimensioning and scale. Size is another essential piece of information that needs to be conveyed about each unit in a sign program, so all design drawings must be dimensioned. The extent of dimensioning depends on the complexity of a given sign type, but at the very least, overall dimensions, height, width, and depth, should be indicated, as well as the dimensions of any components of the sign type. For example, the overall dimensions of a post and panel sign unit are indicated, along with the dimensions for the post component and for the panel component. Dimensions indicating where signs are positioned relative to their surroundings are also important. For example, a typical wall plaque mounting elevation indicates dimensions for the plaque's mounting height and distance from door openings. In addition to being dimensioned, all design drawings must be prepared at scales that can be measured with a scale ruler, typically an architectural scale ruler. See Figure 2.28. The smaller signs in a program can be drawn at full or half size, but larger signs have to be drawn at a smaller scale to fit on the drawing sheet. Again, all drawings must be at a measurable scale that is not reduced on an arbitrary percentage to fit on the sheet. The scale of each drawing should be indicated in writing, and anything that is not drawn in a measurable scale should be clearly indicated as NTS for not to scale. CAD tools and Adobe Illustrator plugin equips AI users to draw and dimension in measurable scales. The importance of measurably scaled, dimensioned design drawings cannot be overstated, particularly to graphic designers who are not typically trained to work at scales less than actual size. Use of dimensions and measurable scales is the only clear, accurate way to convey the sizes of the various sign units within a program. And it's important to point out that the metric system must be used for dimensioning and scaling on any project outside the United States. You'll find the metric system, once mastered, to be much easier to use than the US system. Conveying design information. In addition to providing dimensional information, the design drawings contain a package of information about the sign's program's visual aspects. See Figure 2.29. A checklist guide for the drawings package content includes listing of the graphics vocabulary, including the full fonts of all typefaces, along with all symbols and arrows used, summary of all colors, materials, and finishes used in the program, front, side, and top views of each sign type with callouts, representations of the different graphic layouts for each sign type with callouts, mounting elevations, fixing signs in relation to architectural or site features, sign location plans typically bound in with the design drawings package. Depending on the sign program's design, more or less detailed information may be required than indicated on this checklist. For example, if a sign is a simple flat square wall plaque, top and side views may not be required, since the thickness of the plaque can be conveyed by a callout rather than dimensioned on a side or top view. Similarly, if that plaque is simply glued to the wall, that can be called out as a note rather than shown in a side or top view. However, in the case of a sign that's more complex in any form, say with tapering or multi-leveled panels, all sides may need to be shown: front, back, top, right side, and left side, possibly even along with some sections through it. The drawing number of a sign type's primary elevation, typically the front elevation, since it's usually the most distinctive, is entered into the message schedule for each sign number. See Chapter 6, the Hardware System, for an explanation of these drawing views. The key to the drawings package is to include all the design information about the signs that will affect how they're priced, how they're built, and how they're installed. The goal is to cover all the bases for all the unique conditions in the program. The trick is to do this without being unduly repetitive. For example, several elevations may be required to show the different mounting conditions for a given sign type at different locations, but a typical mounting elevation can be used for a condition that's the same at many locations, such as wall plaques mounted next to doors. At this point, the drawing number for the mounting elevation corresponding to each sign number is entered into the message schedule. In the graphics drawing, the EG designer controls the appearance of the sign graphics for a wide range of message content. The graphics drawings should show each unique layout configuration for each sign type, since a given sign type may display several different kinds of informational content, with each requiring a different layout. Keep in mind that a given layout configuration can be used for any number of similar messages, so it's inefficient to provide a layout for each and every sign message in a program, unless the sign program is very small. At this point, the drawing number for graphic layout that corresponds to a given sign number's message content is entered into the message schedule. Distinguishing between drawings and artwork. It's important to make the distinction here between drawings and artwork for sign graphics. The graphic layout drawings visually depict the graphic arrangement of various kinds of messages, but they are not the actual artwork for the final sign graphics. It's more efficient for the sign fabricator, rather than the designer, to produce the final digital artwork for each individual sign unit in a program. So digital art production is typically the fabricator's responsibility. but it's the EG designer who controls the visual appearance of the artwork by providing graphic layout drawings. Since design firms use computers to produce their design documents, the content and nature of the documents for the design graphics have changed in the pre-computer era. It was typical to highly dimension the graphics drawings because they served as layout grids that the design fabricator used to produce and assemble the final artwork for each sign's graphics. But now that design firms produce their layout drawings as computer files, it's become common for the designer to provide those files as templates for the fabricator to use in producing the final art. And that brings up another important distinction between template files and artwork files. Think of a template as a digital grid, which has typical graphic elements in their specific sizes and arrangement into which new messages are input to create individual artwork files for each unique sign message. Template files have active editable fonts, so the fabricator can input various messages specific for a given layout template to create the final digital artwork file for each sign. Again, sometimes the EG designer will produce individual artwork files for a very small sign program, or for a relatively small collection of signs within a larger program. Once the messages have been input into the artwork files, the fonts are typically converted to paths or outlines, which renders the fonts uneditable, i.e. deactivated, in the final artwork files, to avoid font conflicts with computerized cutting equipment in the fabricator shop. At this point, the fonts become more geometric vector files in the shapes of letter forms, but messages can't be edited in files with deactivated fonts, so it's important for the EG designer to maintain the source files with editable active fonts in case artwork for additional or revised messages needs to be produced. Chapter 5, the graphic system, has more on graphic layouts. Compiling technical specifications. Specifications serve as an adjunct to the design drawings, communicating verbally what the drawings can't communicate visually. As such, the specifications or specs can be thought of as the instructions to the design fabricator. As with the design drawings, the appropriate level of detail and formality of the specifications varies with each project. An entire book could be written about specifications. Indeed, there are professional spec writers who occasionally become involved with signage projects. So, the purpose of this section is to provide only a general overview of specifications related to signage. As mentioned, signage fabrication is part of the construction industry, and the signage specs become part of the fabrication contract, which is typically let by construction industry professionals such as general contractors, GCs, or construction managers, CMs. The actual fabrication contract is a legal document that consists of many more general contractual items than the signage specs, including terms and conditions, often referred to as a boilerplate or upfront conditions, bonding requirements, and others. Thus, the specs that are concerned solely with the product to be constructed, that is signage, are termed the technical portion of the specs. The extent and formality of signage technical specs is dependent on the size and circumstances of each project. On smaller projects, the specs can effectively be incorporated into the design drawings. On larger projects, particularly those for large government or institutional clients, the EG designer may be required to provide highly detailed, formalized specs conforming to the master format established by the Construction Specific Institute, CSI. CSI format specs are in the form of a letter-sized document independent from the drawings. More information about CSI format can be found at www.csinet.org. Most signage specifications fall somewhere between drawing notes and CSI's master format. In detail and formality. Often the signage specs are wordy enough that they're easier to produce at a letter-sized word processing document than put on the drawings. See Figure 2.30. And even if the client doesn't demand strict CSI language, the EG designers should not be surprised if they are told to label the signage technical specs as Section 10.14.00, which is the section of the CSI master format devoted to signage. Note that the 2012 master format has further subcategories, such as 10.14.16 plaques. Under the signage section, nor should the EG designer be surprised to see the signage specs bound into a huge comprehensive specification document for an overall construction project. Two other important tips about the detail and formality of the technical specs. Unless all the specs are treated as drawing notes, there should be as little redundancy as possible between any drawing notes and the letter-sized spec document. There will always be some redundancy between the two, but it's time-consuming to indicate a spec twice or to need to change a spec in two places rather than one. In the interest of clarity and brevity, spec language should be as definitive and concise as possible. Specs are definitely not a creative writing exercise. Typically, sentences are formulated in a somewhat brusque instructional form, such as use stainless steel fasteners for all sign attachments, and use the biblical sounding verb shall, as in all signs shall be attached with stainless steel fasteners. Words such as must, should, and even will are considered too intermediate in intent for spec language. Regardless of the level of detail or formality required, on one level or another, the technical specs for signage should cover at least the following: quality assurance, required submittals, quality/workmanship standards, materials and products, fabrication and graphic application techniques, installation and cleanup. Quality assurance specifies the qualifications fabricators must provide to assure they're capable of performing the work required by the design. This is very important on projects that go out to publicly advertised bidding. As such, projects often draw bids from unqualified fabricators, and qualifications requested may include length of time in business, photos and descriptions of similar projects in scope and cost, list of designer references, square footage of fabrication shop, list of shop equipment and personnel, percentage of work to be subcontracted, and the like. Some EGD firms require that, along with their bid, bidders submit a sample representing the quality and complexity required by the project at hand. Required submittals indicate which drawings, samples, and other items fabricators are to submit for design review as they produce the project. Submittals required for signage typically include shop drawings, artwork for all sign graphics, material, color, finish samples, product literature, and production prototypes. Quality/workmanship standards describe general standards for the quality of work to be performed by the fabricator, such as tolerances, accurate fitting of parts, use of non-defective materials and components, production and finish standards, and more. Materials and product specs indicate specific materials and products the fabricator is to use to produce the project, such as metals, e.g. stainless steel, aluminum, etc., plus specific alloy if necessary for the appearance or integrity of the design. Plastics, paints, stock sign components, electronic displays, and so on. If a specific material or product essential to the design of the project is only available from one manufacturer, the material/product name should be specified, along with the manufacturer's name and contact information. Such proprietary specs are sometimes frowned upon by clients, necessitating additional to the term or approved equal in the proprietary spec. Fabrication and graphic application techniques specify the techniques the fabricator is to use in producing the sign hardware and graphics, such as how parts are to be attached to each other, seamless or seamed assembled, types of finishes and coatings, how graphics are applied, and others. Installation and cleanup indicates how the fabricator is to install the signs and clean up after installation, such as coordinating sign installation locations with other trades or parties, installing signs level and plumb, restoring any adjacent areas damaged by sign installation, removal of fingerprints and dirt from installed signs, and the like. Phase 4 Goals and Results. The primary goal of the documentation phase is to tie up all the loose ends of the sign program's design and clearly communicate the program's design intent to sign fabricators who will be bidding on and then producing the sign program. It's the last design intensive phase of the design process before the design is handed off to the producer. As such, it's the last chance to finalize all outstanding detail, approval, and coordination issues to avoid unpleasant and often costly surprises during the post-design bidding and fabrication phases. Phase 4 results in several documents that convey the final design intent to the client and other parties involved in procuring fabrication of the program. Final sign location plans, final message schedule, final sign graphics drawings, final sign hardware drawings, technical specifications. The EG designer wouldn't have progressed to Phase 4 without client approval of big picture presentation of the program's design in Phases 2 and 3. Therefore, formal design presentations are rare during the documentation phase. Designer-client interaction during Phase 4 is usually more in the form of coordination meetings and document review to resolve all the details of the program, culminating in the client's approval to release the design document for the bidding phase. Coordination between the designer and the client's contracting representative should also occur during Phase 4 to prepare for the bidding phase. Phase 5, Bidding, Post-Design. Finally, the project has been appropriately documented and the design work is done for all intents and purposes. Bidding is the first of 3 post-design phases in the overall design process, and it's the phase in which official binding prices are competitively obtained for the signed fabrication contract, and a bidder is selected for the contract. As with previous phases, the formality of the bidding phase depends on the project at hand. On projects outside the U.S., the bidding phase is sometimes referred to as the tendering phase. Remember, EG designers are very rarely procure signed fabrication services because they don't have the hefty financial or legal resources needed to enter into a construction industry contract. Rather, the signed fabrication contract is let by an outside entity who represents the client, such as a GC, CM, or a government or corporate procurement department. Therefore, the EG designer's role during the bidding phase can be described as advisory. After the designer releases the document package to the client's contract representative, it's that representative's responsibility to compile and assemble the overall bid document package, issue the documents for bidding, administer the bid process, evaluate the bids, and award the fabrication contract. Unfortunately, contract reps sometimes leave the EG designer out of the bidding loop. This is a mistake for 2 reasons. First, the project design firm can provide valuable technical assistance on signage-specific issues during the bidding phase. Second, many contract reps don't have experience with signage packages. Bid phase items on which the design firm can advise the contract rep include bidder qualification, bid form development, invitation to bid, responses to information requests including pre-bid meeting, bid review, contract award recommendation. Bidder qualification. Signs are some of the most highly scrutinized objects in the built environment, making bidder qualifications a very important step in the design process. Simply put, an inexperienced or poorly equipped fabricator can destroy a sign program's design value and create enormous headaches for the entire project team. Also, many owner reps, while perhaps experienced in general procurement, management, or in heavy construction trades, lack the means to assess the capabilities of sign fabricators to successfully execute the type of signage project at hand, while the owner's rep has the experience to assess the financial condition of potential signage bidders. The EG designer has the experience to assess their technical production capabilities. When possible, to achieve a high level of quality control, it's best to have bidders' qualifications reviewed before bids are solicited. The project then goes out for bids from a pre-selected group of quality screened bidders. Many publicly funded projects, however, require open bidding without regard to pre-qualification. In such public funding scenarios, the qualification requirements of the technical signage specs becomes essential for eliminating unqualified fabricators that have submitted bids. The designer's role in the qualification process may be as simple as providing a list of sign fabricators with whom the designer has previously worked or potential bidders for the project, usually a minimum of three, or a bidder qualification may entail much more work on the designer's part, such as reviewing qualification literature and information provided by potential bidders, visiting their shop facilities, conducting interviews with them, and contacting their references to assess past performances on similar projects. In either case, the designer should have no affiliations with nor imply performance guarantees for any recommended or reviewed fabricator. Bid form development. Bid forms provide a standardized means for all bidders to submit their bids, easing the task of bid comparison and analysis. EG designer can advise the contract rep on how to devise the bid form for the project, or can provide the bid form to the contract rep. At C&VE, we favor unit pricing for bid forms, since unit prices avoid much more information for bid comparison than a single lump sum for the entire fabrication contract. At their most basic, unit price bid forms are itemized by the unit price for each sign type times the quantity of each sign type, yielding a total price for each sign type and a grand total bottom line price. Of course, there are many variations. Client reps may want any of the following: the fabrication and installation costs quoted together on a unit basis for each sign type, fabrication and installation costs quoted separately on a unit basis, fabrication quoted only on a unit basis with installation quoted as a lump sum, costs quoted with sales tax included in unit prices, costs quoted with sales tax as a lump sum. It may be helpful to include quantities for each sign type on the bid form, but with the caveat that each bidder is responsible for verifying all quantities. Invitation to bid. The invitation to bid provides specific information to bidders on preparing and submitting their bids. This information can include when and where a pre-bid conference is held and whether attendance is mandatory, when and where to submit bids, contact information for the contract representative, brief scope of work, bid guarantee period, work completion dates, and any other information that may be pertinent to bidding the project. Responses to information requests. Responses to information requests are just that. Bidders sometimes have questions or need clarifications about the design documents, although generally not too many if the EG designer produced a thorough document package. These qualifications can come up in a pre-bid conference, where the EG designer is present to respond, or in the form of official requests for information, RFIs. Bidders are typically required to send an RFI to the owner's representative, who in turn routes the RFI to the EG designer, often via the project architect, if one is involved. The designer then responds via the same channels, usually within a requested time period. A word about protocol during the bidding phase. To ensure a fair bidding process, all bidders should have equal access to the same information. Accordingly, unless otherwise arranged, The designer should avoid responding directly to any given bidder's questions and route all communications with bidders through the contract rep. Bid review. Bid review involves the analysis of the bids submitted by fabricators. The client's rep will usually organize the numerical bid results in some form, such as a table, and the designer should review this information for discrepancies or red flags among the field of bids, which, as an unusually high or low price for a given sign type, or a wide spread between the lowest and highest bids. The designer should advise the contract rep of such anomalies and have the rep request clarification. Contract award recommendation. The contract award recommendation is typically a joint decision involving the contract rep, the client, and the designer. Depending on the project, the factors other than price may play a role in the contract award decision. These factors can include the bidder's conformance with the formal contractual requirements, qualifications, understanding and responsiveness to the project at hand, financial status, as well as others. Phase 5 Goals and Results. The main goal of the bidding phase is for the client's contract rep to award a contract to a fabricator qualified to produce the sign program at a competitive price. This process includes the contract rep's solicitation, administration, and review of bids, with the EG designer performing an advisory role to the rep and client. Depending on the project, Phase 5 can result in the designer providing or advising on certain documents for the bidding process, such as the bid form, invitation to bid, and responses to information requests. During Phase 5, the designer should also be involved in reviewing the bids received by the contract rep and in contract award decision making. Additionally, the designer should attend the pre-bid conference and be involved in reviewing the qualifications and capabilities of the bidder. Even though the designer's role is advisory, during Phase 5, all parties, including the designer, should feel confident the selected bidder is capable of fabricating the sign program to the highest quality standard at the lowest possible price. This sense of confidence is the most important result of Phase 5. Phase 6 Fabrication/installation observation. In this second post-design phase of the design process, the client's contract rep has contracted with a qualified sign fabricator to produce the sign program, and the EG designer's creative solution to the signage problem is physically embodied. This is the exciting moment of truth for the designer, when all the planning, vision, and hard work literally take form. In the fabrication/installation observation phase, subsequently referred to here as observation, the designer reviews the fabricator's work and progress for technical conformance with the design intent, while the contract rep administers the overall mechanics of the contract, such as payment schedules, time schedules, coordination of signage with other trades, routing of project communications, and so forth. In the architectural profession, this phase of the design process is also often termed construction administration, CA, or simply construction phase services. Note that the use of the word administration is somewhat misleading because the overall administration of the contract, including payment of subcontractors such as sign fabricators, is primarily the responsibility of the client's contract rep, not the architect. The EG designer's role during this phase is similar to the architect's during the construction phase, observing and reviewing the fabricator's work and advising the contract rep on its quality and progress in relation to the design intent. Thus, the designer's role is of an advisory rather than an administrative nature, which is why this book uses the term observation rather than construction administration. That said, the EG designer's role during this phase should, however, be much more active than that of a passive, disinterested observer. Activities in which the EG designer should be involved during the observation phase include coordination meetings, submittal review, shop visits, site visits, post-installation punch list inspection. Although some clients, in an attempt to reduce design fees, request little or no designer involvement during the observation phase, it's important to note that the designer's involvement is a key quality control measure during sign fabrication. EG designers are far more experienced with the details that comprise a signage program, and they have the greatest expertise of anyone on the project team to review and assess the fabricator's fidelity to executing the design intent. Certainly, the designer's involvement may be limited in some of the activities listed to reduce design fees. But at the very least, the EG designer should review all of the fabricator's submittals, which include shop drawings and samples, during Phase 6. Coordination meetings. Coordination meetings are important tools during the observation phase, starting with a fabrication kickoff meeting at the beginning of the phase, which the client's contract rep, the fabricator, and the designer attend, along with any other interested project team members, such as the client or project architect. The kickoff meeting helps set the stage for an efficient observation phase, covering such items as the expectations and responsibilities of all parties, identification of any potential problem areas, identification of coordination points and processes, definition of project communications protocols, and so on. After the kickoff meeting, periodic coordination meetings are necessary as sign fabrication progresses, and the designer's involvement with them can vary with the project at hand. In addition to face-to-face meetings, other tools can be used for project coordination, such as web conferencing, teleconferencing, email, an FTP site, or dedicated project collaboration websites. Submittal review. Submittal review is the key role for the EG designer during Phase 6. As noted in the discussion of Phase 4, submittals are items the fabricator prepares to indicate how the sign program will be fabricated, and these items are submitted for the designer's review and approval. Submittals required for signage typically includes shop drawings, artwork for all sign graphics, material/color/finish samples, product literature, and production prototypes. See figures 2.31 and 2.32. Each kind of submittal provides a different piece of information about the sign program's fabrication. Shop drawings indicate how the fabricator will construct and install the signs. Artwork shows the size and layout of graphics for each unique message/sign type combination within the sign program. Material/color/finish samples show the actual materials, colors, and finishes the fabricator will be using on the signs. Product literature provides information and specifications on signage components, such as lighting fixtures or digital display units, which the fabricator purchases from outside manufacturers. Production prototypes are effectively samples of the actual, completely fabricated and assembled signs, with one prototype typically provided for each sign type. Obviously, production prototypes are usually submitted after all the other submittals have been approved, giving the fabricator the green light for actually producing the signals the signs on a trial basis. Approved production prototypes then become the quality standard for the remaining production run, but may also be part of the total sign product the fabricator delivers and installs. Submittal review is a checkpoint process that facilitates coordination and helps catch the mistakes, inaccuracies, and defects and resolves misunderstandings before the sign program is built. It's in the best interest of every fabricator to provide meaningful, complete submittals for design approval, because approved submittals indicate that the fabricator is on the right track in interpreting the design intent of the sign program, thereby minimizing the chances of design rejection after the entire program is fabricated. Most kinds of submittals are sent to the EG designer's office for review via a routing protocol set up for the project. The one exception may be production prototypes, as the prototypes for some sign types may be far too large to transport to the designer's office. Prototypes for smaller sized sign types, however, can be reviewed in the designer's office. Fabricators are increasingly using digital photos and videos taken in their shop to show fabrication details and progress. But since photos don't show everything, they should be considered adjuncts to, not substitutes for, physical prototypes. See Figure 2.33 through 2.37. The formality of the submittal review process varies from project to project, as does the protocol for routing the submittals. The key is to keep all interested parties in the loop, so they're aware of all comments and approvals on all submittals. For this reason, it's best for the fabricator to issue all submittals to the contract rep, who in turn routes them to the proper parties for review. The routing order is reversed after the submittals are reviewed. Although such protocols can be cumbersome, they are vital, as they help prevent mistakes and misunderstandings by ensuring that all project communication is transparent and that all key players are aware of the status of the submittals. It is definitely bad form for the designer to discuss submittals directly with the fabricator without inclusion of the client's contract rep and/or architect. Although in certain cases the contract rep and/or architect will authorize such direct contact. Even when the design document package for a program is very thorough, many of the infinite details of the sign program are worked out during the observation phase. As such, sign fabrication is a give and take process that requires mutual respect between the designer and fabricator. Assuming the fabricator is properly qualified, the two must work together to ensure the design intent is executed as faithfully as possible, and that requires reasonableness and sometimes compromise on both sides regarding submittals. The fabricator shouldn't try to pull any fast ones. For example, trying to convince the designer that substandard workmanship is within acceptable industry standards. The fabricator should also prepare meaningful shop drawings which provide an accurate picture as to how the signs will actually be produced with the fabricator's equipment, shop practices, and personnel rather than an unconsidered rehash of the design drawings. This is now more important than ever, since technology has made it easier for some fabricators to try to pass off design drawings rehashes as shop drawings. Conversely, the designers shouldn't be unreasonably fussy, for example, objecting to fabrication details that don't compromise the appearance or functionality of the design intent. That said, the designer should review submittals very carefully, for once a submittal is approved, it is considered an acceptable standard for fulfillment of the fabrication contract. In most cases, the submittals are stamped or tagged with a review stamp that has checkboxes for indicating the submittal's approval status. Typically, these boxes are labeled in a range from approved, outright approval, to approved as noted, conditional approval, to revise and resubmit, to rejected. Note that some EGD and architectural offices avoid the use of the word approved on their stamps because it may imply the designer's guarantee of the fabricator's performance. In such cases, a less definitive word, such as reviewed or accepted, may be used, depending on project protocol. The review stamp may belong to the EGD office or to another firm on the project team, such as the architect, or the review stamps of both may be used. In addition to the status checkboxes, the review stamp typically contains a disclaimer of the reviewer's responsibility, along with spaces for the reviewer's signature and review date. The review stamp status is accompanied by an applicable review comments written on the submittal. On paper submittals such as shop drawings and graphic artworks, the drawings are typically marked up with review comments in red pencil, hence the term markups and red lines for reviewed drawings. On some projects, other project team members, such as the architect, will mark up the drawings with comments additional to those on the EG designer. It is becoming more common for EG designers and architects to mark up electronic versions of the drawings rather than paper prints by using Adobe Acrobat Pro or a project collaboration application. Figure 2.32 shows a marked up shop drawing. It's rare for all the various submittals on a signage program, particularly shop drawings and graphic artwork, to be accepted outright or conditionally on the first round. It's often a process of revise and resubmit based on the design review comments or less commonly outright rejection when a submittal is so off base that it doesn't even warrant the EG designer's time and consideration. The key is that the fabricator is required to resubmit in a timely manner each submittal item until it is accepted as such. The resubmittal process can become a war of the wills, which requires judiciousness and sometimes compromise on behalf of both designer and fabricator. Shop visits. Shop visits are performed during the course of fabrication to observe the quality and progress of sign production in the fabricator's shop. The need for and number of shop visits varies with each sign program. Smaller, relatively simple programs with just a few sign types that are physically small in size may not require shop visits since production prototypes can be sent to the designer for review. Larger, more complex programs with many sign types that are too large in size to transport to the designer may require several shop visits. The use of digital photos and videos to indicate shop details and progress can help reduce the number of shop visits. See figures 2.38 and 2.39. When shop visits are warranted, they are conducted by the EG designer, often accompanied by the contract rep and/or client. The purpose of the first shop visit is typically to review production prototypes, although on some larger products, the first shop visit may be devoted to project coordination and review of other kinds of submittals. The need for additional shop visits varies with each project, but only one shop visit is covered in the design budget. It's most effectively allocated to production prototype review, during which the designer can discuss any design or fabrication issues directly with the shop floor personnel involved in building the prototypes. The observation and conclusion of shop visits are documented in a memo or the meeting minutes, often with digital photos incorporated which can be recorded by the EG designer the contract rep, or the fabricator. In projects where the records of shop visits are produced by others, the designer should review them for accuracy and completeness before they are distributed to the project team. Site visits. Site visits are typically concerned with coordinating sign installation, such as verifying sign location and mounting heights. The coordination of sign installation details with the adjacent site conditions. As with the shop visits, the need for and number of site visits varies with the sign program size and complexity. Site visit participants can include the EG designer, contract rep, client, and other members of the project team, such as the architect. Digital photos or specific sign location conditions can be sent to the project team to coordinate installation with fewer team members needed at the site. The observations and conclusions of site visits are documented similarly to shop visits. Post-installation punch list inspections. Post-installation punch list inspections are also site visits, but now the EG designer and/or contract rep walks the project site to inspect the signs after they've been installed and enters any defects onto what is termed a punch list, which is why this inspection process is also called punching out. On projects outside of the U.S., a punch list is sometimes referred to as a defects list. On some projects, the fabricator may accompany the punch listers for at least part of the inspection. See figures 2.40 through 2.42. Note that the term defects, as used here, includes not only fabrication defects, but a whole host of other problems, such as missing signs, signs damaged in shipping, signs mounted crooked or in wrong locations, sign installation damage to adjacent construction, and others. The message schedule, which already exists as a complete itemized inventory of every sign in the program, can be readily adapted for punch list comments, including the insertion of digital photos of problematic signs. The contract rep forwards the completed punch list, often accompanied by a memo summarizing general comments, to the fabricator to make any necessary corrections to the defective signs. On a large signage program, the punch list inspection can be very time-consuming and exhausting. So it's important to point out that the design budget may not accommodate the EG designer performing an exhaustive inspection of each and every sign. In some cases, the design budget may not accommodate any on-site inspection by the EG designer. There are, fortunately, some ways to adhere to the design budget in such instances. For one, the designer can inspect all of the signs that receive the most public scrutiny and just spot check the less noticeable signs. Or the designer and the contract rep or client can spend a day together spot checking each sign type, with the designer pointing out what looks for and then heading off the inspection of all the remaining signs to the contract rep or client. Digital photos that show the completed signs as installed are helpful and can actually be proof of work done for payment. Site visits may not be possible on projects with limited design budgets, so photos may be the only way to ascertain how well the fabrication and installation was done. As with submittal review, the punch list inspection requires reasonableness and sometimes compromise. The punch lister needs to know where to draw the line between acceptable and unacceptable products, so the punch list can become an instrument of negotiation. There's also the thorny issue of signs that have been damaged by other trades after the signs were installed, but before they were punched out. For this reason, the sign program should be punched out as soon as possible after installation. After the fabricator has taken action to remedy any defects, the corrected signs should be punched out in a follow-up inspection. This inspection is best performed by the designer, but can also be handled by the contract rep or client. If necessary, aided by digital photos sent to the designer. After all, the work is completed to everyone's satisfaction. The contract rep arranges the final payment to the fabricator, and the new sign program is up and running. It's time for congratulations, handshakes, and professional photography to document the final product of the signage design process. Phase 6 Goals and Results. The main goal of the observation phase is to observe and review the fabrication and installation of the sign program. It is the contract rep who handles the general administration of the fabrication contract, with the EG designer taking on the dual roles of advisor and facilitator on the technical issues relating to the fabricator's fulfillment of the design intent. Phase 6 should result in the EG designer participating in activities that provide review checkpoints for the sign fabricator's quality, progress, and fulfillment of the design intent. These activities include coordination meetings, submittal review, shop visits, site visits, and post-installation punch list inspections. At the very least, the designer should be thoroughly engaged in submittal review and approval, providing review comments and acceptance status marked up on the submittals. The designer's involvement is also key to more effective coordination meetings, shop and site visits, and punch list inspections. Depending on the project, the designer may also be involved in providing coordination memos and meeting notes. Phase 7 Post-installation evaluation. The signage program solution that took so long to evolve to become reality has been built and installed and is, everyone hopes, a huge success. It might seem then that the design process has been concluded in the observation phase and that it's time to move on to another project. Not so fast. Whether formally or informally, paid for by the client or not, every design solution should be evaluated. In Phase 7, the EG designer evaluates the effectiveness and functionality of the operational signage program. The major goal of evaluation is to learn which aspects of the signage program are successful and which aspects, if any, could use improvement. The results of the evaluation phase of a given sign program can be applied to both the program at hand and to other programs the EG designer develops in the future. It should go without saying that, in fact, evaluation takes place throughout the design process, as various solutions and processes are explored, considered, presented, and either selected or rejected. But only after installation can the sign program as a whole be evaluated in its real-world environment. Most often, evaluation takes place informally and without the direct involvement of or compensation to the designer. So how can the designer obtain evaluation input? The two most basic ways are through client feedback and direct observation. After living with the operational sign program and people's responses to it for a while, the client gains insights into the program's strengths and, ideally few, weaknesses. Accordingly, it's useful to contact the client a few months after the sign program is installed to request the client's assessment of the program's effectiveness. At this point, the client may commission the designer to develop any additional signage or make any modifications to the in-place signage that may be needed to fine-tune the program. The designer can also visit the project site and directly observe how people interact with the sign program and how the program fits with its environment. This approach may also include interviews with site staffers who interact with the site's users. The depth and formality of the direct observation approach tend to depend on the geographical distance between the project site and the design office and on whether or not the designer is being compensated by the client for assessing the project. Phase 7 Goals and Results. The primary goal of the evaluation phase is for the EG designer to learn how effectively the sign program solution functions in its operational environment. Phase 7 results in insights and findings that can be applied to the sign program being evaluated, as well as to other sign programs developed by the designer. As noted, the designer may or may not be compensated for performing an evaluation of the sign program, and this tends to determine the depth and formality of the assessment. In either case, client feedback and direct observation are helpful evaluation tools. If the designer is being compensated for Phase 7, a report may be produced that summarizes the conclusion and recommendations of the evaluation process. In any event, after the sign program has been operational for a period, the client may engage the designer to fine-tune the program with additional and modified signs. Chapter wrap-up. That's it for the design process. It's quite a journey, even when delineated in somewhat simplified form. As in this chapter, and no two projects are ever quite the same, so it has a myriad variations and nuances. Design is an evolutionary, creative, problem-solving process, so plan thoroughly, don't jump the gun, keep the ideas flowing, and follow through on everything, from the initial project research to conceptualization to development and documentation of the design, to advise on bidding and fabrication, to evaluating the final sign program. The design process includes a lot of work. It makes concepts become reality and ideally results in a successful sign program and perhaps lasting friendships with other members of the project team.